Okay, so I want to put one more short video together with just a couple examples so that you can see how things operate, even outside of maybe what we specifically talked about in the videos. So in this particular case, now we have an integral with base e, and looking at it, it looks to be a perfect opportunity for a u sub. If we let our u equal the e to the x squared, then the du would be our exponential function copied down, back times now the derivative of the inside, which would be our 2x, and of course we can't forget the dx, in which in this problem it's a perfect fit. All of that is now going to be our du, so all we have now is the integral for cosine of u du, and we know that the integral for cosine is going to be our sine. Don't forget the plus c, and also then don't forget to go back and make sure the answer is in terms of x. So substituting that back in, we come up with sine of e to the x squared plus c. So a pretty direct fit, again, more just kind of as a review type problem. Okay, so now in this next example, you're actually going to be taking the information that we've learned and expanding upon it to this particular case. If you'll think back, we never talked about an integral of a log with anything other than a base e, right? We've talked about the integrals of natural logs, but not integrals of logs with base 5, base 20, base 10 in this case. There's a base 10 here. This is a common log. And so to do these types of things, we're going to use our change of base formula. We're going to do so that we can now get it back into a log base e. So our change of base formula says that this is going to be the natural log of 10x over the natural log of 10. The natural log of 10x, the 10x comes from there, of course, and with this base being 10 right here, even though it's not written, it's an implied base 10 since it's a common log, this is the natural log of our 10 down here on the bottom. Okay? Now, we still also have this x in our denominator as well, so I will put that x down in there with our dx. So now, this 1 over the natural log of 10, right here, the 1 over natural log of 10, that's a constant that I can pull outside of the integral. So 1 over the natural log of 10 comes out, and I now have just the natural log of 10x over x dx. So using our u sub, our u looks like it would need to be the entire natural log of 10x. I say that because we need to account for this x being in our denominator, and then derivative of a natural log is 1 over this thing right here. So we've got a 1 over 10x back times the derivative of the inside, which would be a 10, followed by, of course, our dx. So conveniently, once again, it's a perfect fit. We've got our 1 over x dx, and then we've got our natural log 10 that we substituted out entirely. So this integral now is nothing more than 1 over the natural log 10 with an integral of u du. So to integrate this, add 1 and divide, and then going back into x's, this would be a 1 over 2 natural log 10 times the natural log of 10x quantity squared plus c. So this would be an acceptable final answer for a problem like this. And one other thing they might do, depending on the textbook and where you're looking, this guy right here, remember this 2 could come up, so they might call this the natural log of 10 squared, which would be 100. So something to consider when checking your final answer, but I'd be perfectly fine with this. A really good problem in the sense that it takes all of the knowledge that we've talked about and worked with, and now we've expanded it into a more even broader concept with a log base 10. And so you feel free to use this as needed. I also want to finish up these last few videos by reminding you that these 2 sections that you're going to be working on with these 5 videos, that's a lot of material, guys. So make sure that you're not only watching these videos, but you're reading the text. There's a lot of information in the text that you'll find extremely helpful in mastering the material and starting to work on the homework problems, and then, of course, moving into the exam. So please read the text. They do some things in a little bit of a different order, which gives them an ability to do a few other things as well that I think you'd benefit from studying. So please, guys, not only watch these videos and rework the problems and take good notes, but read that textbook in these two sections. You'll get a lot of good information out of it.